This is Mr. Sand. We're going to talk about satellites today. Satellites are things that orbit other things. So, with that very rigorous definition, I'm going to show you a little thought experiment. It's what Newton called just imagining. Well, I think he just called it the cannon shot. He said, imagine if you go up to a very, very tall mountain and have a strong enough cannon that just shoots a cannonball out perpendicular to the height, I guess the vertical kind of component of the mountain, and parallel to the surface of the earth at that point. If you shoot it out far enough, what would happen? Well, here's a little video of it. If you shoot it, it'll go a while, and then it'll hit the ground. That's if the ground's flat, right? Okay, let's see if we can shoot a little bit. Wow, it goes a little bit further there. Okay. Let's see if we can go a little bit farther. What would happen? Say, oh, here's a super cannon. Here we go. Okay. Really major cannon. Right? And it shoots kablooey. And it goes really far. And it still hits the ground. Okay. But now, if we are on a circular object like the Earth, circuloid kind of object, if it doesn't, there's nothing flat right there, it'll just continue to go, and the curve of the Earth will drop away as it's being attracted to the Earth. So it'll just continue in this orbit around the Earth. That's what Newton thought. And it would come back and it would hit the cannon. Oh, it went over it there. Anyway, it'll just continue going and going and going. Every instant along the way, the Earth is falling away from it as it is falling towards the Earth. So it's not as if this thing is in 0G. And here they're showing the space station. I'll get to that in a second. So it's not as if the thing is in 0G. It's in zero gravity. It is clearly in a gravitational field. It's falling towards the Earth. But the thing is, the Earth is circular, and it is just falling away from this object that's going very, very fast at the same rate as it's falling. So it never hits the Earth as it's going around and around and around. That's what Newton imagined in his little thought experiment, and that's what we use to introduce what a satellite is. It's just falling continuously towards the Earth, but it's got such a very, very fast, you would call this a horizontal velocity here. It's got such a fast horizontal velocity that it never actually runs into the Earth. It just continues to be in orbit. Now, if you shot this with even a faster velocity, it would fall away slower, and it would eventually lose its orbit, and it would just eventually kind of, the gravitational field would not be strong enough to keep it in a circular path. It would just fly off into space. So that's a satellite. That's the concept I want you to get. Now, the only other thing that I need you to understand here is something that's fairly simple compared to the other algebra we've done. Remember when we did FC equals FG? FC equals FG. Remember what FC was? Well, we're not going to go into the full period kind of formulation of FC. We're going to use a simpler kind of formula. Remember the mv squared over r formula? We're going to use that now to compare FC to FG. And here's, again, G M M M1 M2 over r squared. So here we're going to lose our m's, and this is going to be the mass well, if there's a satellite and we're talking about Earth, it's the mass of Earth. Let's just solve this for one of the variables here. I'm just going to solve it for velocity. So I'll first rewrite this, g m2, and remember that's the mass of the Earth, r squared. This will equal v squared over r. Let's multiply both sides by r to get v by itself. So you multiply both sides by r, you're going to get this. You're going to get equals, so v squared, let me write that in first, v squared. Check your algebra skills here. It's going to be g m, stick with the 2, And then if you multiply both sides by r, that means there's an r on the top and there's an r squared at the bottom. So it's just going to leave you with an r at the bottom. So to get v by itself, we're going to just take the square root of this side, m2 over r, and that will give you v. So that's the velocity of something. Okay, this is going to be useful in your problems. So have fun with that. Okay, so what else do we need to talk about? I think that's about it. Okay, good luck. Bye.